Good morning, class. Today we are going to see the last type of isomerism, that is optical isomerism. And in this, first we need to understand the term optical activity. Okay. So for this, we have taken mm, we have taken a sodium lamp. So from this, and the source of light is passed through a slit, so a small hole through which only light can pass. So the light that comes out of it through slit will be nature of polychromatic. That means the vibration will take place in all the directions. The vibration will take place in all the directions. Now, if that light is passed through a nickel prism, okay, nickel prism, then the light that comes out will have only one plane that it's vibrate, that we call plane polarized light. So plane polarized light means light whose vibration takes place only in one plane is known as the plane polarized light. Now this plane polarized light, if it pass through a compound or a solution taken in a test tube, okay, taken in a test tube, and if the plane polarized right rotate towards right rotate towards right, then we call it as dextro-rotatory. Okay, it is called dextro-rotatory. And if the plane polarized right rotates towards uh, left then we call lever-rotatory. Now if this plane polarized light is deflected either towards right or left, then we can call that the compound that we have taken is optically active. We can call that substance as optically active. And if the plane polarized light remains unaffected, then we call it as optically inactive. Okay, optically inactive. So such isomers of an optically active compound, that is towards right and towards left too, are called optical isomers, and the phenomenon is called optical isomerism. And the instrument that is used to measure the optically activity of a substance is called polarimeter. Now we need to understand more in details about it. The concept of asymmetric, chirality, or achiral. Okay, so symmetric means, say for example, if you take a circle and if you divide into half, then the two halves will be symmetrical in nature. That means it will be the same. Or if you just place a mirror in front of a circle, then the image that is formed will be same as the object that is of the circle. Okay, now such kind of compound, okay, such kind of compound where the mirror image is same as the object, okay, and we call it plane of symmetry. An object is said to be a chiral or chiral, okay, if it has a plane of symmetry and the object and its mirror image are superimposable. Superimposable means exactly the same. If you place the one above the other, it will exactly match. Okay, so a molecule having a plane of symmetry or a center of symmetry is superimposable on its mirror image is said to be a chiral. Okay, and chiral molecule means just the opposite. An object or a structure which has a plane of symmetry and is not superimposable on its mirror image is said to be chiral or disymmetric, or we call it asymmetric. Okay, now we need to understand this term achiral and chiral. Okay, so achiral we understood that it means it is the same, the mirror image will be the superimposable on each other. Now if you try to understand the chiral means, over here if you see the left hand in the mirror, you'll find the mirror image of that left hand as the right hand. Just try it. Okay, just try it. Now if you just try to place the left hand over the right hand as the mirror image, it does not superimpose. That means it does not exactly match. Okay, that's why the left hand globes does not fit in the right hand globes, in the right hand. Okay, Now, to make you more understanding, we'll take the example. Say for example, this is a letter O or alphabet O, and if you place a mirror and see the image, then you will find the exactly of that. Such compounds we call achiral, and if you place P, then you'll find in this shape. So this is chiral. That means the mirror image does not exactly superimpose on each other. Okay, so the objects are chiral. The objects are chiral if one object is the mirror image of the other, but they are not superimposable. Now, similarly, now this how achiral or chiral is related to optical activity. Chiral substances are optically active. Chiral substances are optically active, and achiral are optically inactive. Now, we'll try to understand and identify how we can identify the chiral substance. Chiral means chiral carbon atom or asymmetric carbon atom means a carbon atom attached with four different groups. So if you see the example of this 2-chlorobutane is written in this way, and if you look at this carbon atom, and if you see the corresponding groups that is attached, one is hydrogen, other is methyl, this is chlorine, this is ethyl. So all the four groups are different. So this carbon atom we can call it a chiral or asymmetric carbon atom, and such kind of compounds will undergo optical isomerism, and they are called optically active because of the chiral carbon center. Similarly, if you see over here, this carbon atom is attached to four different groups. That means the atoms or the groups are completely different from each other. So this is also chiral. Similarly over here, here, in this example as well, in this example as well. So in chiral molecules, the carbon atom denoted by an asterisk is an asymmetric carbon atom or chiral. Fine. Cause of optically active and optical isomerism. So this is an example of lactic acid. Lactic acid is a substance acid that we found in milk. So this is the one. So over here, this carbon atom is chiral because it is attached to four different groups: one acid group, one alcohol, one methyl, and one hydrogen. Okay, this is also chiral. Okay, achiral means suppose if you have got hydrogen as well over here instead of OH, if you have got hydrogen, then it will be achiral because the two groups are same. Based on that concept, today's assignment, that will be assignment number 9, will be this one. Which of the following are expected to be optically active and why? So out of these compounds, which are optically active and why? So we have understood that how we can identify optically active substance. So for to identify optically active substance, first what do you need to identify? Whether the compound has got chiral carbon or not. Chiral carbon means a carbon attached to four different groups. Say for example 1,2-aminobutane. So first you need to write down the structure. Okay, you can write down the open structure where you can see the all the groups attached to the carbon, and after that just see whether that carbon atom is chiral or not. That means carbon atom, whether it is attached to four different groups or not. So, and just write down out of this which are optically active. Optically active means it will rotate the plane polarized right, and we also already discussed about the plane polarized right. So complete this assignment and send it in my mail.